Hi guys, this is Vineet and I welcome you to this video. Today video topic is considerations regarding Rowstore Columnstore Index rebuild reorganizing operations. So we will talk about both the Rowstore indexes and the Columnstore indexes, and we will talk in terms of index rebuilding and reorganizing operation on these indexes, and we will talk about the considerations. So before we move ahead, I would request you guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon. Select all notifications to get notifications regarding all my upcoming and future videos. The reason I am asking you to subscribe is because I don't want you to miss on any of the videos related to indexing that I will be creating in coming 10 to 15 days. So that's the reason I'm asking you to subscribe. So please go ahead and subscribe right away. I'm waiting for 5 seconds. There's a subscribe button below this video. Click on that button and follow the process. So guys, I hope you must have subscribed by now. If yes, then let's move ahead. There are some points to remember while watching this video. I would recommend watching this video till the end to gain better clarity of the concept. And if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please share in your comments and suggestions, and also provide us any feedback if you like. We eagerly wait for your comments and suggestions, and we love to read the same. So do post in, guys. Let's move ahead. We have created some playlists for you to watch. Some of the popular SQL Server playlists are SQL Server Database Design, Tables, Business Continuity, Indexes, Performance Tuning, Integration Services, and Transact SQL. If we talk about this video pertains to the indexing category and the performance tuning category as well as the database design category. So this video caters the three categories of this playlist. So I posted this video in three places. If we talk about the total number of videos posted on our channel, we have more than 250 videos posted on our channel. You can check out my channel link page given at the bottom of this slide. Also guys, the links to all these playlists and the channel link is also given in the video description area of this video. So please check out the playlist and the channel link. Also guys, why we create playlist for you, there's a reason behind that. The reason we create playlist for you is because we feel that playlists are the best way to learn instead of watching videos randomly on any topic. Playlists are basically a systematic way to learn. So for example, if you want to learn about indexing topic or SQL Server indexing topic, what we would recommend is please go to the SQL Server indexes playlist and watch out all the videos from starting till the end if you want to gain better clarity in that area. Instead of watching a couple of indexes videos here and there, I think there should be a systematic way. You should watch each and every video starting from the beginning till the end. And if we talk about the SQL Server indexing category, we have more than 25 videos posted under this category. So please check out this playlist. Now let's come back to today's topic in which we are discussing about considerations regarding the Rowstore and Columnstore indexes whenever we rebuild and reorganize them. So let me take you to notes directly and let's start discussion on this topic. So first heading will be considerations for rebuilding and reorganizing the Rowstore indexes. I think should be the first topic because Columnstore. So this is for Rowstore indexes. So the correct heading is considerations for rebuilding, reorganizing the Rowstore indexes. So the following scenarios cause all Rowstore non-cluster indexes on a table to be automatically rebuilt. So here we are discussing about the scenarios which cause any of the non-cluster indexes, which are Rowstore or row-based non-cluster indexes, to be rebuilt. So what are these scenarios under which non-cluster indexes are automatically rebuilt? Whenever we create a cluster index on a table, including recreating a cluster index with a different key using the create cluster index with the clause drop existing is equal to on, and we are changing the key column whenever we are creating a new index by dropping an existing, and if we are changing the key of the index, key of the cluster index. In those cases, the non-cluster indexes will get automatically rebuilt. Now, second situation is whenever we drop a cluster index. So dropping a cluster index basically causes the table to be stored as a heap. In that situation as well, all the non-clustered indexes will get recreated in the background. Now, the following scenarios do not automatically rebuild all Rowstore non-cluster indexes on the same table. So now we are talking about the scenarios where the non-cluster indexes are not automatically rebuilt. So what are these scenarios under which they are not automatically rebuilt? Whenever we are rebuilding an existing cluster index without dropping it, whenever we are just rebuilding a cluster index, your non-cluster indexes will not get rebuilt automatically. Now, whenever we change the cluster index storage, so for example, if we move a cluster index from one file group to another file group, it will not cause any non-cluster indexes to be rebuilt. So sometimes we also partition the indexes. In that case as well, your non-cluster indexes will not get automatically rebuilt if we partition the cluster index, or even if we move the cluster index to a different file group. All right. So these two are the factors under which the non-cluster indexes are not automatically rebuilt. Now let's talk further. An index cannot be reorganized or rebuilt if the file group on which it is located is offline or read-only. So this is one of the important points. So if your index lies in a file group that is either offline or read-only, then you will not be able to reorganize or rebuild that particular index. Now, whenever we rebuild all the indexes by using the all keyword during the create index operation, right? Whenever the all is specified and one or more indexes are on a offline and read-only file group, then this particular statement will fail. Now, when an index rebuild occurs, the physical media must have ample amount of space to store the two copies of the index. And when the rebuild is finished, the database engine automatically deletes the original index. So when the rebuild operation goes on, so during that operation time, the operation requires the space for the original copy of the index and for the new copy of the index. So it needs the physical media to hold that much space to hold these two indexes. And whenever the index creation operation completes, the database engine automatically deletes the original index and keeps the new index during the index rebuild operation. Now, when all is specified with the alter index reorganize statement, where we want to reorganize all the indexes on a table, clustered, non-clustered, and XML indexes on the table are reorganized. So whenever we specify all option, all the indexes, whether they are clustered, non-clustered, or XML indexes on the table, these get reorganized. Now, rebuilding or reorganizing small Rowstore indexes may not reduce fragmentation. So in our previous video, we had seen that we were trying to rebuild one of the indexes on the person.person table, and it was a small index and it was still showing as fragmented even though we did reorganize that index and even though we tried to rebuild that index as well. So here we are stating the reason why even after rebuilding or reorganizing small Rowstore indexes may not reduce the fragmentation. So the reason behind is now up to and including SQL Server 2014 version, the SQL Server database engine allocates space using mixed extents. So up till SQL Server 2014, mixed extents are used to allocate the space for indexes and therefore pages of small indexes. So if particularly our indexes are small, so pages related to those indexes are sometimes stored on this mixed extents, which implicitly makes that index fragmented. Now, why? What is the reason if they are stored on mixed extents? Then why they remain fragmented? Mixed extents are basically shared by up to 8 objects. So maybe it can be the mixed extents can be shared by maybe more than one indexes, right? So the fragmentation in a small index might not be reduced after reorganizing or rebuilding it. So that's the reason because the small indexes are stored on mixed mixed extents, and mixed extents are shared by more than one indexes. That's the reason even though you rebuild and reorganize those some of the small indexes, then you will not notice any change in the fragmentation level. Now let's move on to next topic, which is considerations specific to rebuilding a column store index. Now whenever we are rebuilding a column store index, the database engine reads all data from the original column store index as well as data from the delta store. Now it combines the data into new row groups. So whatever data it has read from the original column store index and whatever data it has read from the delta store, the operation combines the data into new row groups and compress all row groups into the column store finally. The database engine defragments the column store. Now how the defragmentation operation takes place? The database engine defragments the column store by physically deleting the rows that have been marked as deleted. So and this happens during the time when we rebuild a column store index. Now let's move ahead. Now starting with SQL Server 2019, we have a utility called tuple mover. Basically the role of tuple mover is to move records here and there. So the tuple mover is helped by the background merge task that automatically compresses. So the role of this merge task is to automatically compress smaller open delta store row groups. So in addition to tuple mover, we have an additional component called merge task that automatically compresses smaller open delta store row groups. What are smaller open delta store row groups and what are particularly open delta store row groups? So open row groups are those row groups where rows can be added. So if your row group becomes full, it gets closed by the system. And whenever we have any open row group, it means that we can insert certain rows into that particular row group. So the role of this merge task is to automatically compress smaller open delta store row groups that have existed for some time determined by some threshold value. It then merges compressed row groups in the delta store. So it performs the merge operation on those compressed row groups where a large number of rows has been deleted. So after compressing these smaller open delta store row groups that have existed for some time, which is determined by the threshold level. So after performing that compression operation, it merges the compressed row groups where a large number of rows has been deleted. And basically this background process improves the column store index quality over the time. Now let's talk about rebuilding a partition instead of the entire table. Now rebuilding the entire table takes a long amount of time if the index is particularly large, and it also requires enough disk space to store an additional copy of the entire index during the rebuild operation. So these two are the factors which should be considered while rebuilding the large indexes. So first of all, it takes long time to recreate or rebuild the large index, and secondly it requires enough disk space to store the additional copy of the entire index during the rebuild operation. So if your table is partitioned by we have not yet discussed the concept of table partitioning. So we will create a separate video on that. So for any partition tables, you do not need to rebuild the entire column store. So basically if we talk about partition tables, we have multiple data files for a single table. So a single table is stored inside multiple data files. So that's the concept, but yeah, we will discuss this concept in our upcoming videos in much more detail. So for partition tables, you do not need to rebuild the entire column store index if the fragmentation is present only in some partitions. So we can rebuild certain partitions only. So we don't have to rebuild the entire column store index, and if the fragmentation is only present in the certain portion of the partition or in some partitions. Now rebuilding a partition after loading or modifying data ensures all data the now rebuilding a partition after loading or modifying a data basically ensures all data is stored in compressed row groups in column store. So whenever a rebuild operation takes place after we load certain rows or modify certain data, and whenever we perform the rebuild operation, that rebuild operation basically ensures all the data stored in the compressed row groups in column store. Now when the data load process inserts the data into partition using batches smaller than 102,400 rows, the partition can end up with the open row groups. So basically, if in a certain partition we add rows that are smaller, number of rows that are smaller than this number 102,400, this can result in a open row groups in the delta store. So open row groups are those row groups where there is a possibility of insertion of any other rows. We can insert more rows into the open row groups in contrast to closed row groups. Now rebuilding moves all delta store rows into compressed row groups in column store. So our rebuilding operation moves the all the rows from the delta store into compressed row groups in the column store. So this is what happens during the time when we rebuild a partition. So whenever we have an option of rebuilding a partition, we don't have to rebuild the entire column store index. So that is the benefit provided by the partitioning. So instead of rebuilding the index on the entire table, we can rebuild the index on the partition itself. Now let's talk about the considerations that we have to give while reorganizing a column store index. Now when reorganizing a column store index, the database engine compresses each closed row group. So we have talked about what are open row groups and what are closed row groups. So closed row groups are those row groups where there is no possibility of any row insertion, whereas for open row groups we can just insert rows into those row groups. So that's the difference between the open row groups and closed row groups. So whenever we perform the reorganize operation on the column store index, the database engine compresses each closed row group in the delta store into the column store as a compressed row group. So whatever is stored in the column store is stored as a compressed row group. So compression takes place on the row groups received from the delta store, and finally these compressed row groups get stored in the column store. Now starting with SQL Server 2016, the reorganize command performs the following additional defragmentation optimization online. Alright, so we have already studied that reorganization operation is performed only in the online mode. It cannot be performed in the offline mode. So during the reorganize operation, the access to table is still available even though the index gets rebuilt during that time or reorganized during that time. During that whole operation, the access to table is available. Now starting with SQL Server 2016, whenever we perform the reorganize operation, it performs following additional defragmentation optimizations online. So in addition to basically compressing the row groups from the delta store and storing them into the column store, basically that is one of the operations during the reorganize operation. This operation has been performed where closed row groups from the delta store gets moved over to the column store as a compressed row groups. In addition to that, following operations are also performed. Starting SQL Server 2016, there are some additional operations or additional defragmentation optimizations which can be performed automatically. The reorganization operation also physically removes rows from a row group when 10% or more of the rows have been logically deleted. So during the compression time, it checks the row groups for any rows that are marked as deleted, and if this threshold level is more than 10%, the operation basically delete all those rows. Now let's take an example. If we have a compressed row group of 1 million rows, and if that row group is showing 100,000 rows as deleted, so out of 1 million it is showing 100,000 rows as deleted. The database engine, what it will do, it will remove the deleted rows and recompress that row group with the 900,000 rows, and which basically ultimately reduces the storage footprint or storage requirements, because now we have to only store the 900,000 rows instead of a million rows, because the 100,000 rows which are marked for deletion are deleted during the compression phase, before the compression phase. Now reorganize operation also combines one or more compressed row groups. So first operation it performs is it compress the row groups from the delta store and store them in the column store. And additional operation it also performs is it can combine one or more compressed row groups to increase row per row group up to a maximum of 1048,576 rows. So a single row group can contain this many number of rows at max. Now, for example, if you bulk insert 5 batches of 102,400 rows each, you will get 5 compressed row groups. Alright, so whenever we perform a insert operation in 5 batches, we get 5 compressed row groups of 102 400 rows. And if you run that reorganize operation, so what this reorganize operation will do, these 5 row groups of 102 400 rows each will be merged into a single compressed row group with 512,000 rows, and this can be up to a maximum of 1048,576 rows. It cannot grow beyond that. During the reorganize operation, the database engine attempts to combine row groups in which 10% or more of the rows have been marked as deleted with other row groups that we have already discussed above, right? It first of all deletes those rows and compresses them, right? And it will also try to merge the compressed row groups, many compressed row groups. And let's take an example here as well. So we have a row group 1 here, which is a compressed row group, and this row group has 500,000 rows. And there is also a row group 21 which is also compressed, and it has 1048,576 rows. The row group 21, which has this many number of rows, which is the maximum capacity for a row group. Now this row group has 60% of its rows marked as deleted. So basically during the reorganize operation, these 60% of rows will be removed from this row group 21, which basically leaves 409830 rows. The database engine favors combining these two row groups. So it will first remove the 60% rows which are marked as deleted from this row group, which will result in 409830 rows. It then combines this row group 21 with 409830 rows with the row group 1 which has 500,000 rows. So database engine will do that combination. It will combine these two row groups to compress a new row group that has 909830 rows, which is basically a total of this and this. Basically, starting SQL Server 2016, first of all, a row group compression occurs in the Delta store, and those row groups get stored in the column store. And also merge operations also happen between the compressed row groups to create a single compressed row group out of multiple compressed row groups. And finally, this compressed row groups, a single compressed row group, gets stored in the column store. Now, after performing the data load operation, so whenever we perform the data load operation, we can have multiple small row groups in a Delta store. And we can use the alter index reorganize to force these new groups into a column store. So whenever we do reorganize, these multiple small row groups get compressed and combined or merged and get stored in the column store finally. So we can use the alter index reorganize to force these new groups into a column store and then combine smaller compressed row groups into a larger compressed row groups. The reorganize operation will also remove rows that have been marked as deleted from the column store. Now, reorganizing a column store index using Management Studio combines compressed row groups together. So even if we perform the reorganize operation on a column store index using the SQL Server Management Studio, it also combines the compressed row groups together, but it does not force all row groups to be compressed into a column store. So it leaves certain kind of row groups. Closed row groups will be compressed, but open row groups will not be compressed into column store. So if we perform the operation reorganization or reorganizing operation through the Management Studio, it will only compress the closed row groups, but it will not compress the open row groups into the column store. To forcibly compress all the row groups, we should use the transact SQL statement, which is alter index reorganize, with this particular option set to on compress all row groups. We can turn on this option, during the while issuing the alter index reorganize operation, we can turn this option to on, so that your reorganize operation can compress the closed row groups as well as the open row groups. So guys, we are done with this video. I hope you like the content of this video. Today we have discussed about considerations regarding the row store and column store indexes while performing the rebuilding and reorganize operations. So first we discussed about considerations for rebuilding, reorganizing the row store indexes. Then we talked about considerations specific to rebuilding the column store index. Then we talked on rebuilding a partition instead of rebuilding the entire table. Then we talked on considerations specific to reorganizing a column store index. So guys, I hope you like the content of this video. If you really like the content of this video, please hit on the like button below this video. And if you have hit on the like button, please go ahead and subscribe to my channel as well. You will see a subscribe button there as well. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding my upcoming and future videos. The reason I am asking you to subscribe is because I will be creating many more videos on indexing topic during the upcoming 10 to 15 days, and I don't want you to miss on any one of those, so that your knowledge can be good after watching all these videos. So please go ahead and subscribe right away guys. I'm waiting for 5 seconds. Please go ahead and do so. So guys, I hope you must have subscribed by now. If yes, please post in your comments as well. Please provide your suggestions, reviews, feedbacks, etc. We love to read your comments and would urge you to post the same. And also guys, if you have a good network of friends, you may share my videos with them. There's a share button below that come below each and every video. You can use that share button to share my videos with your friends over any of the social media platforms. And guys, if you feel that my channel can make a difference in the life of your friends, please ask them to join my channel using the subscribe button. If they are working in SQL Server domain, yeah, you can definitely ask them to subscribe to my channel. I would require this help from your end. I thank you so much for your time on this video today, and you have a wonderful day ahead guys. Thank you.